Our project is on the effects of a high ankling shrug when wearing weightlifting shoes. Our question of interest is which shoe allows for a higher power production in college football athletes? The importance of this is to find out which shoe is the safest and which impacts in range of motion and joint mobility. We are wanting to find the highest power production possible to beat the other teams, and our results could also promote a certain cleat type. The movement we are looking at is the high ankling shrug. The main phase we're looking at is the elevation phase. The intensity of this movement will build up as the bar is driven up the body before the bar is in the elevation phase. The elevation phase starts with the bar at the mid-thigh and continues as the lower body triple extends. The momentum produced after aggressively extending the knees, ankles, and hips to perform a triple extension and the shoulder shrug will allow the subject to elevate the bar up to slightly past the hips. From the ankle extension to the shrug at the top is where we'll be evaluating the different velocities produced based on the shoe elevation. Once the shrug is complete, the elevation is finished and the bar drops back down to mid-thigh or the ground, whichever the subject prefers. And this is a video of one of our subjects performing his shrug. So as you can see, he picked up the bar, he did his descending phase, and then he accelerated through his elevation phase. And since he was doing separate reps, he didn't drop the bar in between sets. He just dropped it after he was finished with all of his sets, or his reps. So our overall performance objective was to drive against the ground with the ankles, knees, and hips, explosively performing that triple extension maximally and vertically. The background of a three-point stance and a defensive lineman. This is the movement of interest that we were looking at. The D lineman will fully extend the lower body to blow full force into the offender or the offensive line. The criteria of a three-point stance is the head being neutral position, the upper body in a 45-degree angle, lower body in a 90-degree angle within the front leg, and the feet are hip-width apart on the balls of his feet. And the purpose of the stance is to get his most power and leverage to produce the most explosive force that you can against these linemen.
The mechanical sub-goals for the elevation phase is to move the bar as fast as possible in the shortest amount of time. This will create the highest velocity. To get this, you're going to want the highest force production in order for the move to be the most explosive. We expect that the weightlifting shoe will produce a more explosive movement than the training shoe. This is because the weightlifting shoe has that solid, firm base, and so all of the force that you push into the ground is going to elevate you up. This is Newton's third law. It's the law of action and reaction. Okay, so our hypothesis that we stated was that, our alternative hypothesis was that we were going to test an elevated heel in a weightlifting shoe, which would create a larger power output than a regular training shoe. And then our null hypothesis, we said, would be an elevated heel in a weightlifting shoe that will not create a larger power output than a regular training shoe. So increased force into the ground, which would equal an increased ground reaction force. To do this, we measured the peak bar velocities and we correlated to power production. So the methods that we used, we decided to split our testings into 2 different days where some of the participants, which were 5 of the college football players here at WKU, would be wearing the Olympic lifting shoes, which is a heel elevated shoe with no cushion, on one day, and then the other participants would wear a Metcon 6 training shoe, which is a very flat shoe, on the other day. Alongside all of these criteria, we have also included some exclusion criteria, which deals with any illnesses that they may have or previous surgeries that they've experienced the past 3 months. Before we begin, we wanted to make sure that all our participants were healthy and well enough to perform this experiment. So in our in our PowerPoint here, we listed what the participants were, their ages, which were 19 to 23 years old. We recruited them from the head strength coach. They had to be experienced in Olympic lift, and there was no current or prior injuries, like I said before. Testing, we were testing a high hand clean shrug. The warm-ups were 15 minutes long, and then 2 tests. We did 3 sets of 4 repetitions. The first set was at 55%, second 75%, the third was 95% of their 1 RM, and like I said, we split these into 2 days of testing. Okay, for this slide, this is our material slide. So the first shoe that we provided a picture of for you in the right corner is the Nike Savlos weightlifting shoe. It is a 15 millimeter lifted shoe, which increases mobility and has a hard insole inside of it. So with this shoe, we found a study. This article called "The Kinematic Changes Using Weightlifting Shoes on a Barbell Back Squat." This states that the purpose of the weightlifting shoes is to protect lifters' feet and provide a stable, firm stance on the platform. Because of these properties, the article says this shoe will allow for greater vertical force production required during heavy lifting. To also add on to this, another study on the effect of weightlifting shoes on the kinetics and kinematics of the back squat found that the weightlifting shoes helped increase depth and mobility by increasing knee flexion and hip angles. Now, the next picture we provided is another shoe, the Nike Metcon 7 training shoe. It is a 4 millimeter lifted shoe, and it is has an absorptive insole. These shoes are known as running shoes. They're also designed to absorb repetitive shocks from walking and jogging.
To collect our data, we're using a device called a mini tendo. It straps around the end of a barbell and shows the bar velocity output. We're using this to test the 95% of their 1 rep max and to analyze the peak velocity. This chart is showing the average velocities for each participant for weightlifting shoes versus their training shoes. On the y-axis is the average velocities in meters per second, and then on the x-axis is each participant. And then the average age group for these participants is 19 to 23. The average body mass is 88.9 kilograms. The average height is 184.63 centimeters, and then the max lift average is 105.68 kilograms. And we're calculating velocity, but the relationship between velocity and power is force times velocity equals power. We chose to use a paired t-test to show our data for this experiment because a paired t-test is used to compare 2 population means in which the observation in one sample can be paired with the observations in the other sample. Our paired t-test gave us a p-value of 0.66 compared to the alpha of 0.05. This means that our data is insignificant and we cannot reject our null hypothesis. Despite our findings being insignificant, we expected to see that the weightlifting shoe would provide a higher force production than the training shoe because of vertical ground reaction force, which states that whatever force you put into the ground is going to repel you up at the same amount. And we expected that the weightlifting shoe would provide a higher force back up into the air because of the firm base, whereas the training shoe has an absorptive base, so some of that force that they're putting into the ground is going to be absorbed into the shoe and not propel them up the same amount. The formula for power is force times velocity, so if we expected to see a higher bar velocity with the weightlifting shoe, then we can expect a higher power as well. Newton's second law states that force equals mass times acceleration, and acceleration is change in velocity over change in time. So if there's a higher bar velocity, then there's also going to be a higher force production, which would also be a higher power production. So some reasons why our data or our findings might be insignificant could be due to sample size being too small. So we were only using 5 participants, and just by random selection, these 5 participants may not perform as well as if we had done 10 participants or 15, but due to just availability, we could only have 5 participants. There could also have been some equipment failure, so this might mean that the device that we're using to record our velocities
could have a low battery, or we could have had the strap too tight to the bar, which will track movement in the bar and not just like the up and down movement or the Y movement. We could also, we were testing athletes after their workout. So if, depending on how they performed in their workout prior to the test, that can also have an influence on our data. And then shoe size, we were using the same shoe for each participant. And so if there's any variances in shoe size, like if the shoe was too tight for one participant or too big for another, that might also have an influence on how they perform. And then one other thing that might cause our data to be insignificant is individual biomechanical differences. So if somebody just so happens to have better hip mobility or ankle mobility than another participant, then that can also skew our data. And that can also play into sample size, because if we had a larger sample size, then that could have taken care of some of the variability within our participants.
Now I'm going to talk about the articles that we found relating to our hypothesis. So one of them being the effects of footwear on performance in a barbell back squat, even though that we're not looking at that same exercise of a high ankling, we can still use the concepts and relate them to each other based on force and power output and even center of mass. So in the study, they found that the peak vertical force and power didn't differ in weightlifting shoes and regular shoes, and they just used a normal running shoe. But they did find that the total center of pressure migration was reduced in a regular shoe. This means that the flatter shoe gave a more stable body position, which may produce a more effective lifting technique. And we hypothesized that the weightlifting shoe would give a more stable position because it was a harder ground. So that differed, which was unique to find the difference in those studies. Another study that we looked into was the squat biomechanics in weightlifting for foot attitude effects. This found that the wedge increases stability and reduces the load on the knees and ankles. For this study, 2 subjects went through a protocol. The first result was based on the foot attitudes, and when attitudes are placed on foot anterior part, the knees position goes into a forward direction towards the foot tip, and on the contrary, when the attitude is on the rear of the foot, knee remained on the back and its position is always behind the foot tip. This was confirmed based on the markers in the heel for their squat cycle. They had a lot of different graphs that showed the different biomechanical movements for this, and we could correlate it to ours as our different subjects having different stances, which could skew our data for our results. And their other results identified an articular angles at the ankle, knee, and hip with the tech shoes and the bare feet. And their graph had just shown that there was an increased range of motion when using shoes versus barefoot. So now relating to football, the principle of equilibrium states that the 2 forces must be equal, opposite, and collinear to remain motionless. A defensive lineman is at static equilibrium when holding their 3-point stance prior to the ball being snapped. They must be very stable to keep their equilibrium. Stability is the resistance to both linear and angular acceleration, which should be maximized in this position in football. Newton's second law shows that the more massive an object is, the greater the force is required to produce a given acceleration. So being that the defensive linemen are trying to get to the quarterback and past the offensive linemen, they must produce a greater amount of force than they are getting in return. So the 3-point stance gives the player leverage, allowing them to produce the most explosive power that can be exerted. So overall, our findings are statistically insignificant. Therefore, we cannot say that weightlifting shoe will or will not produce a higher power production. Through our research, we can conclude that a higher power production is expected with weightlifting shoes due to all of our biomechanics background and Newton's law.
And these are our references.